Welcome everyone to the new video. So in this video we are going to talk about a very important topic, that is the radical addition reactions. So far I have talked about the two name reactions, and apart from that I have also talked about the Barton-McCombie deoxygenation, that is deoxygenation reaction. So in this video we are going to talk about all the addition reactions that these radicals undergo. And in this video I have probably covered so many examples that none of the questions that will be asked in GATE or NET will be outside the content that I have in this video. इस वीडियो के अंदर मैंने बहुत सारे एग्जांपल लिए हैं, सारे के सारे रेडिकल केमिस्ट्री के एग्जांपल इसमें हैं जो कि रेडिकल एडिशन रिएक्शन के अंडर आते हैं. तो अगर एग्जाम में कोई भी आपसे पूछा जाएगा नेट में या गेट के अंदर ना, वो इसी वीडियो के अंदर जो भी एग्जांपल कवर किए गए हैं उसी में पूछा जाएगा. और अगर आपको कहीं पे कंफ्यूजन हो रहा है तो कोशिश करेगा कि लॉजिकली मैकेनिज्म्स ना उसका ड्रॉ करने की कोशिश करें, आप सही आंसर पे अपने आप अराइव कर जाएंगे. ठीक है. So before starting my video, again I would like to request you guys to comment on my videos. Actually source बहुत ज़्यादा important है. Comment on my videos and let me know about the kind of content I'm posting and what kind of videos do you wish to see and what kind of improvement should I make. I need your involvement because at the end of the day I am making these videos only for the benefits of all the students. I would be the first person to be absolutely delighted with your success in NET exam and GATE exam as well. Okay, so comment on the videos and subscribe and let me get to the 1K subscribers. And obviously, as you know I'm going to distribute the t-shirts to few of the subscriber with Unlock Chemistry logo. So in the radical addition reactions, actually what happens, we know so far that in presence of, whenever we have a carbon-carbon double bond and carbon-carbon triple bond, these radicals, they have the ability to to undergo addition on those bonds. For example, if we have a double bond and to this there is a functional group that is attached, then this radical undergoes addition. Suppose if this Z group is hydrogen, then this is the relative rate with which the addition takes place. And you can clearly see if this Z is an electron withdrawing group, then the rate of such addition becomes quite high. That is going from 65 to 2300 as we move from phenyl to aldehyde, because the conjugation is increasing. Okay. And this reaction itself makes the basis for the polymer chemistry. Polymer के अंदर हम बहुत सारे जो polymerization करते हैं ना, उसके अंदर addition reaction ही होते हैं, and this in itself makes the basis for that. Okay, so here as such I have included one of the examples. So this we know tributyl tin hydride and AIB, and why do we use this system, इसके बारे के में मैंने जो Barton-McCombie deoxygenation का वीडियो बनाया था, आप वो चेक कर सकते हैं, उसका लिंक डिस्क्रिप्शन में अवेलेबल है. बहुत ही अच्छा वीडियो था. उसमें मैंने ये एक्सप्लेन किया कि हम ये कैटालिटिक सिस्टम हम क्यों यूज करते हैं, हम बेंजाइल पेरोक्साइड वाला सिस्टम क्यों यूज नहीं करते कभी भी रेडिकल केमिस्ट्री के अंदर. ठीक है. सो इसके अंदर हम जैसे देख सकते हैं कि यहाँ पर हमारा कार्बन आयोडीन बॉन्ड क्लीव होता है और यहाँ रेडिकल जनरेट होता है, और जैसे ही रेडिकल जनरेट होता है ये इसके साथ कॉन्जुगेट एडिशन में जाता है, तो आपका प्रोडक्ट ये वाला हो सकता है. हम क्लियरली देख सकते हैं रिएक्शन कंडीशन माइल्ड है, और इस कंडीशन के अंदर आपका एसिडोनाइट लिंकेज और बेंजिल प्रोटेक्शन इनको कुछ नहीं होता, दे स्टे एज सच. ठीक है. दूसरा जो अब मैं रिएक्शन यहां दिखा रहा हूं, दिस इज अ वेरी वेरी इंपॉर्टेंट रिएक्शन बिकॉज हियर देयर इज एन कॉन्जुगेट एडिशन ऑफ दिस alkyl radical onto the double bond, and it is taking place selectively from alpha phase. Okay, and you can see the distereoselectivity is 25 to 1. So what is happening, let us see. So in presence of this tributyl tin hydride, there is a generation of a radical here, and we have a chiral auxiliary. Since this chiral auxiliary is occupying the beta phase, so it means a conjugate addition of the radical is going to take place from the alpha phase. ठीक है. अल्फा फेज से एडिशन होता है और हमें बहुत अच्छी डायस्टीरियो सेलेक्टिविटी मिलती है. सो दिस टू, इनफैक्ट दिस इज अ वेरी वेरी इंपॉर्टेंट एग्जांपल दैट यू शुड बी माइंडफुल ऑफ. सपोज नेट एग्जाम में आपको दो स्टेप में भी पूछा जा सकता है, एंड आफ्टर दैट दे कैन आस्क यू द एडिशन ऑफ लिथियम हाइड्रोक्साइड एंड H2PO2, देन यू शुड रिमेंबर इट इज द ऑक्सीडेटिव क्लीवेज कंडीशन ऑफ दिस chiral auxiliary, and you will end up getting the carboxylic acid over here. Okay, so this is a very very good example. Now if we talk about the mechanism, as I said before here, so the first step in itself is the cleavage of this carbon iodine bond to generate this alkyl radical. Okay, and in the next step, this alkyl radical adds on to the olefin, and in the last step, this olefin takes its hydrogen or the proton radical from the tributyl tin hydride. Now there are important things to consider about this particular mechanism. कुछ चीजें जो बहुत ज्यादा इंपॉर्टेंट है, ये जो आपका कार्बन सेंटर रेडिकल फॉर्मेशन हो रहा है ना, आपका यहाँ पर ये वाला रेडिकल फॉर्मेशन हो रहा है, दिस शुड बी फास्टर. ये जैसे ही है, दिस शुड फॉर्म फास्टर देन द हाइड्रोस्टाइनेशन ऑफ द एल्कीन्स. क्योंकि आपका क्या हो सकता है कि व्हाट इज हैपनिंग दैट ये रेडिकल आपका इस एल्कीन पे ऐड हो रहा है. आपका ऐसा भी तो हो सकता है कि आपका ट्राइब्यूटाइल टिन स्टेनेट रेडिकल इस ओलिफिन पे ऐड हो जाए. ठीक है, तो इसके लिए ये ऐसा ना हो, आप क्या करते हैं? आई होप यू आई गो अगेन. ओके, सो व्हाट डू वी ट्राई टू मेक श्योर दैट दिस एल्कीन्स ऐड ऑन टू द alkyl radical rather than this tributyl tin radical adding on to the alkene, in order to make sure that the addition of this carbon center radical takes place much faster on the alkene. What do we make sure that the generation of this alkene, this alkyl radical is much faster? और ये कभी हो सकता है कि अगर हम एक रिएक्टिव सबस्ट्रेट लें, इसीलिए जो हम अपने सुटेबल प्रिकर्सर होता है ना, हमेशा एल्काइल आयोडाइड लेते हैं, क्योंकि हमको होता है कार्बन आयोडीन बॉन्ड है वो इजीली आपका क्लीव हो जाएगा, एल्काइल रेडिकल बहुत जल्दी जनरेट होगा. जैसे ही एल्काइल रेडिकल आपका जनरेट हुआ, वो इमीडिएटली इस पर अटैक कर देगा. अगर आपका एक कार्बन और आयोडीन बॉन्ड या कार्बन या कोई भी बॉन्ड वीक हुआ, तो आपका ट्राइब्यूटाइल टिन हाइड्राइड ओलिफिन पे ऐड हो जाएगा और आपको इस तरह का रेडिकल मिल जाएगा. एंड दिस इज नॉट व्हाट यू वांट. ठीक है, so here I have represented one more example, which is again a very very important example. Here what we are using is that we are using iodine and we have this methyl acrylate tributyl tin chloride. Just see this thing, this is very important, 0.1 equivalent. We are going to talk about this in the next slide. And then sodium borohydride, and we are using mu, means we are radiating with the light, and we are using sodium borohydride 1.2 equivalent. So what is happening? There is a generation of a radical, it is adding into a conjugate manner, and this is followed by protonation. अब हम क्या कर रहे हैं, एसिडिक कंडीशन के अंदर हम इसको क्या कर रहे हैं, एसीटोनाइट. हमें पता है कि एसीटोनाइट लिंकेज वीक लिंक है, ये जैसे ही आपका टूटता है, आपका ये OH फ्री होता है, ये इसके साथ इलेक्ट्रोनाइज हो जाता है. ये बहुत ही ज्यादा इंपॉर्टेंट एग्जांपल है नेट या गेट के पॉइंट ऑफ व्यू से. ठीक है, ध्यान रखिएगा. तो अब हम इसके ऊपर बारे में थोड़ा सा बात कर लेते हैं. अब क्या है ये, होता क्या है कि देयर इज अ लॉट ऑफ issues when you are using this tributyl tin hydride, because the residue that form, they are very very toxic, and they are very difficult to remove from the reaction mixture. Apart from that, this tributyl tin hydride can lead to various radical abstraction from different sides, so they are competing hydrogen abstraction reactions. So उसकी वजह से हम क्या करते हैं, we have limited the use of tributyl tin hydride, and what we are doing, we are taking sodium borohydride in excess. Now उससे होता क्या है कि रिएक्शन कंडीशन के अंदर कैटालिटिक अमाउंट ऑफ ट्राइब्यूटाइल टिन हाइड्राइड आपका जनरेट होता है, विच इज गुड इनफ टू क्लीव दिस कार्बन आयोडीन बॉन्ड एंड जनरेट अ रेडिकल, एंड थस एडिंग ऑन टू एन एल्कीन. ओके, इसका हमारा ये वाला रोल होता है. ठीक है, अपार्ट फ्रॉम दैट, इट हैज ऑल्सो बीन सीन ट्राइब्यूटाइल टिन हाइड्राइड को यूज ऑफ, जैसे कि अवॉइड कर सकते हैं अगर हम टिन या सल्फर रेडिकल हम यूज करना शुरू कर दें. ओके, दिस इज वन ऑफ द मेजर डेवलपमेंट्स दैट हैपन आफ्टर that. Okay, so this is very important. From the, let us suppose if we are appearing in an interview and if we are asked this question, okay, can we get rid of this tributyl tin hydride, can we develop a protocol which is in which we do not use tributyl tin hydride in excess? Yes, you can say yes, we can use tributyl tin chloride in catalytic amount, and then we can add sodium borohydride. So this is one of the protocol. Then again, if we say we want to just get rid of tributyl tin hydride, we do not want to use tributyl tin hydride or any source of tributyl tin hydride, then you can say yes, we can go for this organostenate type of compound, okay, where we can generate these allyl radicals much more easily. Okay, so what we can do, we can just then there was a development of, this area which we called the use of allyl tributyl tin hydride. ओके, इससे क्या होता है कि जैसे ही आपका रेडिकल जनरेट होता है, ये ऐड करता है आपका ट्राइब्यूटाइल tin hydride वाले स्पीशीज पे, तो आपका इस तरह का रेडिकल जनरेट होता है. और यहां से क्या होता है, ये रेडिकल आपका इधर आया, इसका ये इधर आया, तो आपका ट्राइब्यूटाइल tin रेडिकल यहां जनरेट हो गया और आपका ये एलाइल मॉइटी आपकी जनरेट हो गई. सो दिस इज प्रॉब्ली वन ऑफ द बेस्ट मेथड टू इंट्रोड्यूस द एलाइल ग्रुप ऑन टू द कार्बन बॉन्ड. एक्चुअली क्योंकि हमको पता है कार्बन केमिस्ट्री के अंदर एलाइलेशन रिएक्शंस आर वन ऑफ द मोस्ट इंपॉर्टेंट रिएक्शंस. ओके, सो इफ वी हैव अ सबस्ट्रेट लाइक दिस, यू कैन सी there are 1 2 3 4 4 chiral 5 chiral center in these molecules, and the conditions have to be milder. So what we are using AIBN. So in presence of radical initiator, we generate a radical here which adds on to this double bond, and it results in the formation of this annihilation, and we can see it proceeds via restoration of the configuration. So there is no, क्योंकि रिएक्शन वैसे भी इस कार्बन पे हो रहा है, तो इस कार्बन की स्टीरियोकेमिस्ट्री में तो कोई चेंज आना भी नहीं चाहिए और आया भी नहीं है. ठीक है, और जैसे कि सी, okay, so what happens, let us suppose if we know such type of compounds also, they form radical pretty easily. Okay, and in this case also the approach of this tributyl tin stranded is from the लेस हिंडर कन्वेक्स फेस ऑफ द रेडिकल. ओके, क्योंकि आपका ये जो फेस है हम देख सकते हैं, दिस इज अल्फा फेस विच इज ब्लॉक्ड बाय दिस एसिडोनाइट ग्रुप. सो द ओनली वे दिस radical can approach is from the beta phase. So once there is a generation of a radical, you can clearly see it approaches from the alpha phase. जबकि यहाँ पर जो radical generate होगा, there is an equally likely possibility of being of the attack from the top phase as well as from the bottom phase. But the radical chooses to attack from the beta phase because the alpha phase is blocked by the azidonide radical. So you can clearly see the selectivity in this case as well, and this is the sole product that is obtained in this case. Similarly, if we are dealing with such a system, this again in my first video I've discussed about that we can generate radical on the selenides, on the sulfides. So that is a very very useful video. You can probably see, you will be able to understand why there's a radical generation at this position. Again in this case, if you are not using any additive, the kind of selectivity you observe is 62 to 37. Okay, means there is a generation of a radical here, and since this is OH is beta, so the allyl radical approaches from the alpha phase. So this is what you get in 63%, and the beta phase you get in 37%. But if we are using a coordinating reagent, so what we are using is the trimethyl aluminum, and we can clearly see how does this trimethyl aluminum helps in the फॉर्मेशन ऑफ दिस पर्टिकुलर आइसोमर इन एक्सेस. अब ट्राइमिथाइल एल्युमिनियम क्या करता है, ये OH के साथ और इसके ऑक्सीजन के साथ कोऑर्डिनेट करता है, जिसकी वजह से वो हमारा जो बीटा फेस है वो ब्लॉक कर देता है. सो ओनली एडिशन जो होता है वो हमारा होता है अल्फा फेस से. सो दिस प्रोडक्ट इज फॉर्म्स इन दी major quantity, and this is these two are these every example that I present in my videos is a very important example, and that is how this reaction takes place. This is a mechanism. Now again, vinyl sternates are also very good substrate acceptors of radicals. So again, in this condition, whenever you see a bromo, chloroiodo, there's a generation of a radical here. Once the radical is generated here, and it simply adds on to the olefin in the conjugate manner. So these two are examples of that only. So here also there's a generation of a radical, and this is the isomeric ratio in which both the compounds are formed. Okay, and I would like to bring your attention to this particular example because I feel this has a very high probability of being asked. Okay, so whenever you have a cyclopropane ring or an epoxide, okay, whenever you have, just remember, whenever you have a cyclopropane ring or even an epoxide, and there is a generation of a radical next to it, suppose there had this been an epoxide and there is a generation of a radical, I mean next to it, there is a rapid fragmentation of ring, as a result of which ring wishes to be relieved from any sort of a strain. So ring strain होके आपका ये वाला compound बन जाता है. The mechanism is very easy. So this is your task. Let me know in the comment section that were you able to reach from here to here. But this is a very important example. Remember this, high probability again of being asked in the exam. And then if we have a substrates like this, and these substrates are also, again, whenever you have these type of bond, oxygen, nitrogen, as I said in my previous video, and you expose it to the presence of the light, then what happens, there's a defragmentation that takes place. So if you take this compound and methyl vinyl ketone and irradiate, and this is something that you end up with quite a different sort of a compound. So this is the entire mechanism with which it is taking place. So in the first step, there's a defragmentation to generate the O- radical. So as soon as this radical is formed, the driving force for this reaction is the elimination of the CO2 from the media, which forms this alkyl radical. Now as soon as this alkyl radical is formed, it undergoes conjugate addition with the methyl vinyl ketone. followed by the addition with the sulfur radical that was ejected in the first case to give you the product. So this again is a very important reaction which tests your basic knowledge of mechanistic chemistry. Apart from that, these if we reduce these mercuric salt with sodium borohydride, they in itself provide an alternative method for the generation of carbon radical species. This is again a very important example. We have already studied how the mercuric adds onto the double bond. होता क्या, आपका नाइट्रोजन यहाँ ऐड करता है और आपका मर्क्यूरिक एसिटेट बन जाता है. दिस इज समथिंग दैट यू फॉर्म. नाउ in presence of sodium triacetoxyborohydride, what happens, there is a generation of a radical at this position. So this provides one of the alternative method, and this is very important. I'll tell you what is why. Let me first of all explain the entire sequence. Okay, so there is a generation of a radical here which adds on to the methyl acrylate to give you this sort of a compound. In this condition, what you are doing, you are carrying out the hydrogenation and reduction, which gives you this cyclic compound, which is very, very important. Now, there could be a situation where you could be asked that going from here to here, what sort of a mechanism the reaction goes through. So you should know that whenever you have these alkyl mercuric halides or alkyl mercuric acetates, it could have been a halide here as well, but in this case it is acetate. And when you treat them with any sodium borohydride or any borohydrides, what do you generate is a halide radical at this particular position, which adds on to the conjugate manner. Okay. Now we are going to consider few of the intramolecular radical reactions which give rise to the product. Okay, so suppose if we have a substrate like that and we clearly generate a radical here using tributyltin hydride and AIBN, as which AIBN is nothing but azoisobutyronitrile. So this can rearrange to give this can just simply undergoes protonation to give you 70% of that, and there's an addition to give you 5-membered and 6-membered product. They subsequently give rise to the product. So we see the product which is 5-membered is 81%. So in case of radical chemistry, it is always a 5-membered product which is preferred over the 6-membered. Just always remember this. That is why I decided to take up this example, because this clearly depicts the formation of 5-membered over the 6-membered. You can clearly see this has formed only in 2% yield. Similarly, in this case as well, you can clearly see there is a formation of cyclic structure. There is a formation of a radical here, which adds on to the alkene to give you 5-membered over the 6-membered. So these are very, very important example. And again, in the example below, the same example has been depicted, but the important thing to note here is the stereochemistry. So once you generate a radical at this position, it can add on to this olefin. Now in this case, we have the a site where the radical is generated, and the alpha beta unsaturated ester within the same molecule. Now this radical can add on to this carbon from alpha phase and from the beta phase. We can clearly see there are 3 functional groups. We have this particular benzoyl group and acetonide protected from the beta phase. So the preferred route for the addition of this radical is going to be from the alpha, which is what is clearly reflected. That is why the stereochemistry is alpha in this case, and still what we end up getting is 91 to 9. So this product is formed in majority of excess, and here again 5-membered is preferred. Here also the 5-membered is preferred, and anyway the 5-membered is the preferred route, because the radical that will form as a result of the addition here would be resonance stabilized. Now let's talk about 3 more examples. Here also this is an example which is quite important. So again, once you generate this radical adds on to the double bond and it generates a radical here, which adds on to this one. So we can clearly see this is a formation of 2 5-membered ring, when there is a possibility of formation of 6-membered ring here. Just keep in mind the stereochemistry at these 2 positions, which makes this compound or makes this example very, very important. Okay, now let's talk about the other example. Here also, once you generate a radical here, it adds on to this center to give you the 5-membered. Yeah, again this was a possibility of 6-membered, but since we have already said it is always the 5-membered which is over the 6-membered in the case of radical chemistry. So apne dimag mein cheez, just keep this in mind. Okay, So there's an addition on this side, and there is when these bond moves, and this entire, this sulfide radical, it just goes off to give you the desired compound. Okay, so below there are two more important examples. The reason why I say important is because here again there's a formation of one, two, three, four, five membered species. But whenever there's a methyl group next to the radical, then it would prefer to form bond and keep these two functional groups away from each other. So the both the methyl group or trans are formed in major and the other one is minor. But as the methyl group moves one carbon away, the cis becomes the major and the other one becomes the minor. So in the radical chemistry, sometimes it is the observation that you get what kind of product distribution. On the basis of that, you decide your explanation, or you try to find what could be the reason for that. And again, few more examples. In all the cases, you will see it is the formation of 5-membered which is preferred over the 6-membered. Here also there is a generation of radical under these conditions, which adds on to the double bond to give you the cyclase product. Same with the selenites, addition of the double bond to give you the 5-membered product. Here also, to give you the 5-member product, just look at the stereochemistry. Important thing to note down the condition, that is they are using triethyl borane and catalytic oxygen. So this is a very very good example. That is why I've decided to include their mechanism as well. इसका mechanism मैंने include किया. तो होता क्या आपका triethyl borane में जैसे आप catalytic oxygen डालते हैं, there is a generation of ethyl radical. आपका ethyl radical क्या करता है, फिर आपका यहाँ पर कार्बन ऑक्सीजन बॉन्ड क्लीव होता है and it results in the formation of ethyl iodide निकल जाता है and this radical is formed. And this adds on to the double bond पे add हो जाता है to form this radical. The stereochemistry here is the cis. Okay, so this is something that is observed. Okay, and now the radical that is generated, it plucks up the proton from the S3PO2 और आपका desired product is formed. So your desired product is formed, which is what you want. Now what happens in the other reaction sequence? Once this radical is formed, this equilibrates to form this O negative onto the oxygen, which takes the which releases the ethyl radical and takes up the B diethyl group. So that is how this ethyl radical is now ready to be used in the next cycle of the molecule. That is why you need it in the catalytic amount. Initially you need the catalytic oxygen to generate this radical, and after that this is self-sustained reaction. Initially there was a lot of debate about the mechanism of the reaction, but this reaction sequence of the mechanism completely proved that it follows the radical mechanism. Okay, so just keep in mind the stereochemistry at all these places. Okay, it is very very important. Now what about the alkyl radical if from borane and oxygen? What is seen when you mix these trialkyl borane and alpha beta unsaturated compound and in presence of water, what do you observe? There is a conjugate addition by the alkyl group onto the double bond. Means आपका alkyl group जो borane का, it adds onto the double bond in a conjugate manner when you take it in the presence of water. Again, initially it was thought that the reaction proceeds a pericyclic reaction, but the Professor H.C. Brown, he proved that the reaction takes place via radical mechanism and you need an oxygen just to initiate, and it is a and the oxygen in its triplet diradical form, means there is a diradical that is present in the reaction condition. So this is how it takes place. You can clearly see boron and both the R1 and R2 group, they are planar to each other, and here we have these empty orbitals on which these diradical they adds up in the SN2 passion. So that is how the reaction actually initiates. So this oxygen is required to initiate the reaction. So this adds on to this borane, which releases this whatever R group that is attached, R dash radical, which adds on to the olefin in the conjugate manner. So once it does, it results in this formation of this enolate radical, and this enolate radical again takes up this adds on to the borane, releases one more alkyl radical, which just enters into the next cycle just like in the first case, and you have something like this boron enolate. If you just simply quench this boron enolate, what you end up getting is the desired product. So this is a very very important reaction from exams point of view. And again, This is the example of that. So you have the double bond, you treat it with the borane. So this is exactly what you have. You have this trialkyl borane, and what you have is the alpha beta unsaturated ketone. If you take it in presence of catalytic oxygen, there is a alkyl group transfer. So one of the alkyl group has been transferred in a conjugate manner. So वो यहाँ पर add हो गया, ठीक है? That is just goes to show the एफिशिएंसी ऑफ द एंटायर प्रोसेस जो हमने अभी डिस्कस की, और बहुत इंपॉर्टेंट रिएक्शन है इसकी. अगेन इसकी बहुत हाई प्रोबेबिलिटी है पूछे जाने की. अगेन हमने कई मेथड देखे जिससे हम रेडिकल जनरेट कर सकते हैं. देयर इज वन मोर मेथड व्हिच टेक्स एडवांटेज ऑफ वन इलेक्ट्रॉन रिड्यूसिंग एजेंट जिसका नाम है सेमेरियम आयोडाइड. और इस साल के नेट एग्जाम में जो मैं यहां बताने वाला हूं उसके बारे में ऑलरेडी एक एग्जाम क्वेश्चन पूछा जा चुका है, ठीक है. So here we are using one electron reducing agent, samarium iodide. So आपका क्या होता है कि whenever you take a carbonyl compound and you add samarium iodide, what it does, it just gives away one electron. So what do you form? You form a carbon radical. You form a radical on the carbon atom, and if you just simply reduce it, what you end up getting is the alcohol. And this just self-dimerized to give you the pinacols. If it undergoes, if it condenses with one more molecule and give you the eliminated product. And let us suppose it has a very good ability to add onto the alpha beta unsaturated esters to give you this cyclic lactones. So this is a very good property that these one electron reducing agent samarium iodide has, ठीक है. तो इस बार जो क्वेश्चन पूछा गया था आपसे वो यही पूछा गया था, एंड यू कैन क्लियरली सी देयर विल बी अ जनरेशन ऑफ अ रेडिकल हियर एंड SMI2 in presence of this alpha beta unsaturated this is methyl acrylate. What will it give you? It will give you this 5-membered lactone. So this was the right answer. You can clearly see the content we discuss here is directly applicable to the kind of questions that you are asked in the exam. And just to one more thing. So if we have an alkyl halide radical like that, and if we are using carbon monoxide, AIBN, and organotin, organotins, it generates the radical, it adds on to the carbon monoxide, and then there's a conjugate addition that takes place to give you such compound which on dissociation gives you this species. So this is again a very important example, and again a very high probability of being asked in the exam. ये क्या हो रहा है, just simply यहाँ पर add हो रहा है. आपका clearly देख सकते हो mechanism मैंने दिखा रखा है, simple है, ठीक है. Apart from that, there are other methods which are used to generate this tributyl tin radical, और ये modern method है जिसके अंदर what do you use is ditertiary butyl hyponitrile. So you have this hyponitrile species. Whenever you see such species, just clearly imagine the इसके लिए driving force would be to release this nitrogen. So this is very similar to isobutyryl nitrile. उसको भी आप हीट करते हो तो नाइट्रोजन रिलीज हो तो आपको रेडिकल मिलता है, और इस केस में भी जब आप इसको हीट करते हो तो व्हाट यू गेट इज टर्शी बुटॉक्सी रेडिकल. जैसे कि एल्कोक्सी रेडिकल है, जैसे टर्शी बुटॉक्सी रेडिकल है. और ये टर्शी बुटॉक्सी रेडिकल ऐड होता है आपका हेक्साबुटाइल टिन पे. हेक्साबुटाइल टिन पे रेडिकल होकर अगर ट्राइबुटाइल टिन हाइड्रेट जनरेट कर सकता है. तो आपको इस तरह का एक्सोटिक रिएक्शन दिखा दिया जाएगा. सो डोंट गेट कंफ्यूज. सो द सोल पर्पस ऑफ दीज रिएजेंट्स दैट आर शोन बिलो इज टू जनरेट दिस ट्राइबुटाइल टिन रेडिकल. और ट्राइबुटाइल टिन रेडिकल क्या कर रहा है, वो यहाँ आपका रेडिकल जनरेट कर रहा है, और वो आपका यहाँ पर क्या है, वो ऐड हो रहा है एजाइड के साथ. सो व्हाट यू आर डूइंग इज गेटिंग एजाइड हियर. अगेन द एडिशन इज टेकिंग प्लेस फ्रॉम द सेम फेज, क्योंकि आपका क्या है कि हाइड्रोजन के आपका हाइड्रोजन बीटा फेज पे है, और आपके ये वाले जो फंक्शनल ग्रुप ये का है अल्फा फेज से, क्योंकि हाइड्रोजन आपका लेस बल्की है या फिर लेस स्टीयरिक है, तो इसीलिए जो आपका एजाइड का जो अप्रोच होगा वो होगा सेम फेज से. दैट इज व्हाई दिस डायस्टीरियोमर इज इन द मेजर एक्सेस एंड दिस इज इन द लो एक्सेस, ठीक है. सो इस वीडियो के अंदर हमने देखा जो भी आप रेडिकल एडिशन रिएक्शन के बारे में आपको जानना था सबका सब इस वीडियो में, और आप अगर इस कंटेंट को फॉलो करेंगे तो मैं आपको 100% श्योरिटी देता हूं आप एक भी क्वेश्चन रेडिकल केमिस्ट्री में मिस नहीं करेंगे, ठीक है. Thanks a lot for watching the video. Comment on the videos and let me know whether you like the video or not. कुछ और questions हो बताइए मुझे, ठीक है, और सब्सक्राइब कीजिए चैनल पे. Thanks a lot for watching the video. Have a nice day. Thank you very much.